Good morning, children. Welcome to online physical science classes. This is standard 7 physics. Today we are going to start the new unit 6, sound. Okay, what is sound? How sound is produced? Sound is a form of energy and sound is produced by vibration. Anything that vibrates will produce sound. Okay. The larynx is the organ that produces sound when we speak. So, which produces sound when we speak? The larynx is the organ which is present in our um, in our body. Okay, in our human body is responsible for this, for our voice. So this larynx is responsible for the voice which is produced by the humans. Okay, and when we speak, they vibrates, the vocal cord vibrates, and because of this vibration the larynx produces the sound, and that is how we speak. Okay, children. Okay, good, fine. Okay, now the properties of sound. Among the properties, we need frequencies for a sound. Okay, frequency is the number of vibration made by the source in 1 second. Its unit is hertz. Hertz. What is the unit of frequency? Hertz. Hertz. Okay, the unit of frequency is hertz, and it is symbolically represented as Hz. Okay, small letter, capital letter H and small letter Z. Hertz is the unit of frequency. And what is frequency? Frequency is the number of vibrations made by the source of sound in 1 second. Okay, do you understand? Yes, the loudness of the sound is also called its intensity. We can call the loudness as the intensity of the sound. Intensity of the sound, it depends on the amplitude. The amplitude is the maximum displacement of a source during its vibration. Okay, do you understood? What is the loudness of the sound? How loud the sound is called its intensity, and this intensity depends on the amplitude. Amplitude means the amplitude is the maximum displacement of a source during its vibration. Okay, if a vibration is taking place, how long the object vibrates or traveled during that vibration is called its amplitude. For example, the object is at rest position. This is the rest position of the object. For example, you are winding a thread. The thread, you are just winding the thread vibrates. Okay, so the up to where the up to the maximum distance it's covered. No, this is the maximum distance it covered. So that is called as the amplitude. That is called as the amplitude. Do you understand? From the rest position, how much distance it has covered? This much distance it has covered, isn't it? So that is called the amplitude. This amplitude indirectly responsible for the loudness, that is intensity of the sound. The amplitude is the maximum displacement of a sound during its vibration. The sharpness or dullness of a sound is called its pitch. Okay, the sharpness or dullness of a sound is called its pitch. It depends on the frequency. So the pitch, especially this word is used in singers. Okay, the sharpness and dullness, that is the called pitch, and it depends on the frequency. The pitch depends on the frequency of the sound. Okay, and another important property of sound is quality. Okay, do you understand? Quality. See here, some pitch of the some sources are discussed here. Large drum, it has loudness high and pitch is low, whereas the loudness is high, whereas the pitch is low. Siren, both loudness and the pitch are high. Sound of a mosquito, loudness is low but pitch high. Sound of a refrigerator, both are low only, loudness as well as pitch. Okay, do you understood this, children? Hope you have understood. Another important property of sound is quality. Quality is the pleasant or unpleasant nature of a sound. It is also that property of a sound by which we identify its source. So the pleasantness also is called as the quality of the sound. This is also a property of the sound. So far what are all the things we have discussed as the properties of sound? Frequency, the first one is frequency. uh, then what is the second one? Second one is the um, quality. And what about the next one? The next one is amplitude. And then the next one, amplitude. The fourth one is what about fourth one? Fourth one is the loudness. Okay, loudness. All these are properties of a sound. And also pitch. Fifth one is pitch. 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 All these are qualities of sound. Frequency, quality, amplitude, loudness, pitch. All these are what? The quantities are the properties of sound. Do you understood, children? Yes. A single sound has several frequencies. A minimum frequency or the fundamental frequency is called a first harmonic. Okay, the minimum frequency or the fundamental frequency is called first harmonic. Other frequencies called overtones or integral multiples of this frequencies. They are also called the second harmonic, third harmonic, and so on. We identify a source by the pattern of its harmonics. Okay, so what is a harmonic? Harmonic is the minimum frequency or fundamental frequency. That is called as the first harmonic. Do you understand, children? And a single sound can have many frequencies. And these frequencies, because of this harmonic only, we can identify the source by the pattern of this harmonics. Do you understand? Now the propagation of sound. How does the sound propagates? Propagates means traveling of sound. Okay, sound do not travel through a vacuum. Sound do not travel through a vacuum. It can travel through all gases. Sound can travel through all gases. It travels much better than solids and liquids than through air. Okay, sound does not travel through vacuum. You must keep in mind. Sound does not travels through vacuum. What is a vacuum? Vacuum is the empty space where there is no air present. Okay, for this you can try this experiment. Take a glass jar, fit the glass jar with a doorbell, and close the mouth of the jar with a rubber cork, and then attach a vacuum pump to its bottom. Then after removing all the air that is creating the vacuum, make the bell to ring. You can't hear the sound. You are not able to hear the sound. That is because that sound does not travels through the vacuum. It needs a medium to travel. It needs a medium to travel. Okay, medium in the sense it may be air or water or something else. Okay, so it needs something to travel. And in which medium the sound travels well? To answer this, sound can travel well in gases. Okay, it can through all gases travel much better than, it travels much better than solids and liquids than through what? Air. So for this you make a bell to ring, and you can hear the sound very loudly. The same bell, when you place it in a water, in a beaker of water, and make it to ring, the sound will be less. This is because the traveling of sound will be less in the water or liquid medium. The similar thing, you keep a metal rod between you and your friend, and place it near to your friend's ear, and try to talk through the metal. The sound will be less than the original one. Okay, a metal pipe is kept means, and you try to speak, the sound will be less than the original one. This is because sound travels less in solid than in air. Okay, children, do you understood? The sound needs a medium to travel. It does not travel in vacuum. It travels much farer better than in gases when we compare with solids and liquid. Do you understood this? Similarly, sound travels as waves of compression and rarefaction. Okay, sound travels as waves of compression and rarefaction. A wave is a disturbance that travels through a medium or space. Wave is a disturbance that travels through a medium or space. Okay, when you throw a stone to a pond, it makes waves. No, a similar way sounds also travels in the medium. Okay, the a wave is a disturbance that travels through a medium or space. The particles of the material do not travel. So the particles do not travel, whereas the sound alone will travel. Sound waves are longitudinal. See, actually the water will not travel, only the waves travels, right? Similarly, here also sound only travels, whereas the air particles or water particles or solid particles will not travel. Do you understand? Yes. Sound waves are longitudinal waves. In longitudinal waves, the vibration of the particles are in the same direction as that in the wave travels. As that in the wave travel. As the wave travels, the vibration of the particles also in the same direction. The vibration of the particles as well as the traveling direction of the wave sound wave traveling is also will be in the same direction. And light waves, when you compare this with the light waves are transverse waves. Transverse means in a transverse wave the vibrations are at right angle to the direction of propagation of wave. You know the difference between right angle. What is a right angle, isn't it? They are moving in an different direction. Okay, they, if you compare the angle between the particles direction and the by particles traveling direction and the sound direction, they will be in the, so for example the sound also travels in this direction, the particles also vibrate in this direction. That is called to be longitudinal directions, longitudinal waves. Do you understood? Whereas in the case of light waves, no, light also travels in waves mode only. Light travels in a different way. That is, the particles, if the particles are traveling in this direction, the light waves will travel in the direction which makes an angle of 45 degrees to the particles direction. So this is called as transverse waves. Okay, this is called as transverse waves. Do you understood this? So sound travels as longitudinal waves and light travels as transverse waves. Hope you have enjoyed today's class very well, children, and understood the class also. So complete your assignment and report in the group without fail. At the same time, you have to prepare well for your upcoming exam, children. Thank you. Meet you again.